We have a problem to solve, and pause the video if you would like and see what the problem we have. 1 squared plus 3 squared plus 5 squared, and it goes, and the nth term, see the nth term is given like this. Each term actually is expressed as 2n plus 1 squared. See here, when n equal to 0, if you plug that n equal to 0 here, because it says each term can be, the value of each term can be received when you substitute n equal to that value here. So here n equal to 0, we have 1 squared. When n equal to 1, it will become 3, so it becomes 3 squared. When n equal to 2, it's 5 squared. So when you plug it in the n, 2n plus 1. And what is when you plug it in n plus 1, which is the next term? Plug that in, right? 2 times n plus 1 plus 1, right? Which is equivalent to 2n plus 3. And here it says, if you have the nth term, this is the keyword to watch, okay? For the nth term, when you add up all these terms up to n, you just plug the n here into the formula. For example, let's take 2. So 2 is, when n equal to 2, what is the expression is saying? It's 1 squared plus 3 squared plus 5 squared. So this is equivalent to 35. Pause the video if you want to. So plug 2 here, right? 2 plus 1 and 2 times 2 plus 1, 2 times 2 plus 3 by 3. That gives you 3 times 5 times 4 plus 7 by 3 equal to 35. See that? It matches. So you are going to put the nth term here. So we have n plus 1. You have to plug it in n plus 1. So the one we are trying to prove is, if you plug n plus 1 in the expression, you will, that's what you have to achieve, okay? So I will keep this paint here itself, and I will take another paint to solve this problem using induction. Alright, so it says, again, let me pause the video. Okay, I copied the problem here in another paint. So now we will plug it in. I'm not going to do all the basic step and assumption and all that. We straight away go into start proving the inductive hypothesis, right? Which you have to plug it in, right? So 1 squared plus 3 squared plus 5 squared plus 2k plus 1 squared, and the k plus 1th term we're trying to get, right? The k, we said 2k plus 3, right? Squared. This is what we're trying to achieve. You see here, 2n plus 3 is the next term, so we got it. So let's go and put it back here. So what do we have now? So we know this particular term is equivalent to that term, right? This particular term. So let's plug it in. Plug it in, and so we have k plus 1, 2k plus 1, 2k plus 3 by 3 plus 2k plus 3 squared. So here, if you see now, what all I did was, this sequence I substituted with what our assumption is, right? That's what I plugged it in, plus our n k plus 1 term. That we need to solve for it. That's it. So that so far the task that we did is to find the n k plus 1 term, which is the crucial in all these things, and we have to plug the right hand side, substitute the right hand side, right? Now you need to solve for this equation. You need to solve this for the equation, right? How do we solve it? Let's go 2k plus 3, 2k plus 3 is the common, so I'm going to take that factor out. 2k, that will give you k plus 1, 2k plus 1 by 3 plus 2k plus 3, right? Then it I know you will not be offended if I just multiply it by 3 and divide by 3 to get a 3 as a common denominator. So 2k plus 3, so it is k plus 1, 2k plus 1 plus 3 times 2k plus 3, and the whole 3 is the 3, right? Then what do we have? In the next step we are going to expand this, right? So you know k plus 1 times 2k plus 1 can be written as 2k squared plus k, 2k plus 1. If you add this up, 2k squared plus 3k plus 1. So we are going to substitute that 2k plus 3. I'm going to take the 3 out. We don't need the 3 inside. So I said we unwrap this parenthesis to get 2k squared plus 3k plus 1, right? Plus unfold this parenthesis 2. So 3 times 2k is 6k plus 3 times 3 is 9, right? Good job. Good job. We are progressing. And you see here 2k plus 3 by 3, right? And we are going to put them together. So 2k squared plus 3k plus 6k gives you 9k plus 1 plus 9 is 10, right? And here I'm going to simplify. This is the, you need to pause the video right now and see how do I, right? How do I, where am I heading? First of all, I'm heading somewhere a pattern along this, a equation along these terms, right? So, and let's see if we can factor it, okay? The way I would do that is 2k plus 3, okay, by 3. I think we don't need this guy. I don't know. And here the magic you have to do, okay? Here I would do is 4k. I'll split the 9k as this comes with practice, solving problems and all. So I just split this 9k into 4k and 5k. All right. Now I'm going to solve this 2k. Let's see here. 2k squared plus 4k plus 5k plus 10. Why don't we take 2k common between these two terms? 2k. So 2k is k plus 2, right? And then here I'm going to take 5 as common. So that gives me k plus 2. And now I have k plus 2 as common. I'm going to take that out. 2k plus 5. See that? So plug it in. Plug it in. So you will get 2k plus 3 by 3 times k plus 2 times 2k plus 5. Okay, so pause the video and copy this one if you want to, because I'm going to erase this guy. Okay, and I'm going to, we almost solved it. It's all done. It is, the problem is done. Now I'm going to just copy this guy in here, in here somewhere, just because I don't have a space. Actually, you know what, I will take another paint. Okay, we are trying to revisit this guy. So now so I'm going to reshuffle this. Remember that we are trying to express in terms of k plus 1, right? Remember that our term is k plus 1. So that's where we are heading, k plus 1. Where is it? Okay, I think we erased that, right? Didn't we? No, I think we have one more to go. There it is. We are trying to go here, express everything in n plus 1, which is k plus 1. Let's go there. Not there. Yeah. So now if we express this k plus 2 as k plus 1 plus 1. About 2k plus 3 can be expressed as 2k plus 1 plus 1, right? And 2k plus 5 is k plus 1 plus 3, right? So substitute all of that. Substitute all of that. For k plus 2, we say k plus 1 plus 1, right? I'm going to put a big parenthesis for that. And 2k plus for 3 is 2 times k plus 1 plus 1, right? And 2k plus 5 can be written as 2 times k plus 1 plus 3 divided by the whole thing divided by 3. And you see, my friend, what we wrote is 1 square plus 3 square plus 5 square plus 2n plus 1 square plus 2n plus 3 square can be written as, this is, remember, this is n plus 1, right? N plus 1 term is, can be written as, from what we wrote here, right? What we derived, this is what we derived, right? See the matching. See that? Oh, see that? As k plus 1 plus 1 to k plus 1 plus 1 to k plus 1 plus 3 by 3. This is exactly where we did, right? This is where we tried to prove, and we got it what we want in a way, right? If you see, I'll try to make it a little smaller. So you see, n plus 1, k plus 1 plus 1, 2n plus 1 expanded to 2 times k plus 1 plus 1, 2n plus 3 is, you see how I went from right hand side, from left hand side, sorry, and substituted the our assumption to here, right? And then I solved step by step, and here I did a magic. Of course, this is something, it comes by practice, right? This is the magic I did. I split this 9k into 4k plus 5k to get a good factor, and then I so if you see the red things is what we did the magic, right? We did the magic, the red stuff. So you have to basically practice and solve all the problems like this. Thank you.